Hey guys, welcome back to Rishab's Engineering. Today problem is longest increasing subsequence. Um, and given an integer array nums, we have to return the length of the longest strictly increasing subsequence. Okay, an array is given to us, and we have to check that what is the longest strictly increasing subsequence, and we have to return the length of it. Uh, the strictly increasing subsequence is like the chain of increasing numbers. Let's see in this example, like in this case he has taken, like, if you take this 2, our next greater number is 3, and if you check what is my greater number to this 3, then it is 7, and you can take 101. You can also take like 2 and the greater number is 5, 2 5, this way 2 5, and next greater number to this 5 is 7, and next greater number to this 7 is the 101. Let's try to take this example. Let's say I have this 10, 9, 2, 5, 3, 7, 101, and 18. Let's try to take subsequences from this 10. From this 10 I have my next greater number is 101, and yes, I don't have any greater number to this 101, so this is my one subsequence. If you try with 9, I have my next greater number is 101, and yes, I don't have any greater number to this 101, so this is my one subsequence from 9. But I also have, like, from this 9 I also have 18, my next greater number, so I can form like 9 and 18, and this is my one subsequence. Let's say from 2 I can take 5. From 5 my next greater number is 7 and 101. In this way you can form the subsequences, and if you check here, 4 is your answer, because this is your largest longest increasing subsequence, right? Can you guys think of a way, like, suppose if you are taking this 10, and can you form different subsequence from this 10? Like, if you take this 10, you will say, like, I have 101, this is my one subsequence. Let's say if I have 9, you can take 101, and this is one subsequence. But wait a minute, you also have, like, from 9 you have 18, and suppose if there is 10, so you also have 10, and if you suppose there is 11, 12, so from 9 you have different possible subsequences, so your answer might like more than n square maybe. Can we little optimize here? Can you guys think of an approach, like, suppose if you want to calculate a max subsequence for any particular I index, let's say you just need to know, like, what is your max subsequence for every index before this I index. Like for this 0, should know, like, what is my max subsequence till this array at I minus 1, and you have to take care of two conditions here. Like, let's take a j index, and j index range should be from 0 to I minus 1, and that for this value at I index, this value should be greater than this, the value at j index. And the next condition is, like, you have to find the max for all the j index, and if you are able to find the max for this j index, you have to just add +1 for this I with this array at j index, and you will get the max subsequence for this array at I index. Like what I'm saying, let's see in this example. For this 10, I do not have any value before this 10, so this is my 1. I only have 1 because 10 is my also one subsequence. Let's say for this 9, I do not have any value less than this 9, so this is 1. For this 2, is my 10 is less than this 2? No. Is my 9 less than this 2? No. So this is 1 also. And for this 5, do I have any number less than this 5? Is 10 less than this 5? No. 9? No. This 2? Yes. This 2 is less than this 5, and I only have one value, so I will add +1 and I will get 2 for this 5. And for this 3, I have this 2, and if you add +1, I have 2. I'm adding +1 because I have to take current number also. And for this 7, I have 2. Yes, I also have 2, but will it be my max or not? No. Let's see this 5. Yes, 5 is also less than this 7, and 3 is also less than this 7, but I have to take the max of these 3, and you can take 5 or 3, and you have to add +1. You will get 3, and this is your max subsequence for this 7. And in this way you are able to calculate. And you will notice one thing, like while calculating this, you are able to find your max in this whole array, your max longest strictly increasing subsequence. So this is the approach. Let's try to code this up. We have dp array, and it should be of nums total length, and we have to make our 0 index 1 because I only have one subsequence and do not have any number before. So let's run the loop from I is equal to 1 till this nums total length, and let's take a j index starting 0. We also have to trace max. Let's say it's 0 here, and we have to take care of this condition that till this I we have to check our j index. So, and what we have to check? We have to check like if my nums at this j is less than the I, and will it, like the number at this j, will it be my max or not? We have to check that. And we have to check we don't have to check in this nums, but we have to check in the dp. And let's increment this j, and after taking the max we have to assign our this max to this current I, and it should be max +1. We have because we have to take the current number also, right? And we can trace our answer also. This, and we have to return that answer. Let's see if this runs or not. Yes, it is working. Let's submit this. It's not working for 0. I think I missed one base case here. If my nums total length is equal to 1, I must return 1, because there is always one subsequence, right? Let's try to submit this now. Yes, it is working, but it's taking, I think, a lot of time. uh, let's discuss the time complexity for this approach. So I am using two nested loops, so it should be like big of n square, and I'm taking one DP array, so space complexity will be big of n. Try to think in a better way to do this. Can you guys think like whenever I'm taking the next number, we will create a new subarray for that, and if that number is greater, so we will add that in all the previous subarrays. Let's say I have this 10, so this is my new subarray, and my next number is 9, so 9 is not greater than this 10, so let's make a new subarray for this. I have next number is 2. 2 is still not greater than this 9. Let's make a new subarray for this. I have 5. Yes, I can add 5 in this subarray. My next number is 3. Yes, I can add 3 in this 2. My next number is 7. Yes, I can add 7 in this both two subarrays which start with 2 and 2. Let's say this 2, 5 and 7, and 2, 3 and 7. My next number is 101. So these are my all previous subarray, and 101 is greater in all these subarray. So let's say this 10, and I have 101 I can add, and my 9 I can add 101, and 2, 5, 101. Two, 3, 101. 2, 5, 7, 101, and in the last case you can add 10, and at the end you have to turn the length of the longest subarray. But this might lead me to the poor performance because I'm using extra space and time, so I have to little think in a better way. um, can I do it in a single array? Let's say I have this 10, and my next number is 9. Can I say that my 9 is smaller than this 10? Please replace this number. My next number is 2, and it's still smaller. My next number is 5. So if my 5 is greater than this last number in the array, please add the number in this array. And my next number is 3, but 3 is smaller than this 5, so replace this 5 with 3. And my next number is 7. Let's add 7. My next number is 101. Let's add 101. My next number is 18, or I can say like, if I have 18, please find the nearest greater number to this 18 and replace that number. And because I have 7, but 7 is still smaller than this 18, I have 101. Please replace this with 18. And suppose if I have a number like 4, I have to go in this array, and I have to say like, what is my just my nearest greater number to this 4, and replace that with. And I know like this is my sorted array, and I can apply binary search here. So this is my approach, and it will work. Let's try to code this up. let's say I have a list, and let's go through this loop uh, from 0 till this length of this nums, and I will say like if my list is empty, please add the current number in my list. Or I can say please get the last number in this list and check if that number is smaller to my current number, and please add that number in the list. Else I have to find the index, and my index should be like if I have my 18, or if I have this 14, this 4, I have to say like please look in this array and find just greater number, and I have to find that index, like in this case is 7. So I can apply here lower bound binary search, like or you can directly say this lower bound, and we have to pass this list and current number, and my index is there. Please now set my number on that index, and at the end I have to return the size of that list. Let's define our function here, lower bound. My return type is int, my left is 0 and my right is the last index in this list. And I can apply binary search. Let's take mid. This will return me the mid, and if my mid is smaller than this num, I have to say my left is left plus 1, and there is another case. I can say let's make my right as the mid, because I have to found the just greater number. So this is the slight modification in my binary search, and return my left. Let's see if this work or not. Yes, let's submit this one, and yes, it is working. Let's discuss the time complexity here, because I know I am looping through this array, and at the same time I am applying binary search, so my time complexity will be like big of n log n. This is for my current loop, and this is for the binary search, and my space complexity will be big of the maximum subsequence array, because I know at the end my list will be the maximum subsequence array. So this is my space complexity. If you find this video helpful, please like and subscribe. Thank you.